A small block of mass m is released from rest from the position shown in the figure. Mass of wedge is 2m and radius of curve surface is r. Friction is absent everywhere. For question number 17, if wedge is kept fixed by some external force, then, well, this small block will be moving along this direction. It will reach the maximum speed here and again reach to this much of the height in other side. So I would say at this point it still have the maximum speed. And how much it is? All the mechanical energy, that is actually potential energy in the beginning, will now convert into the kinetic energy. So simply 1 by 2 mv0 square, I would say it is mg into r. Or how much is the velocity v0 here? We are getting this part to be as 2gr of square root here. So option A is the wrong answer actually. Maximum normal force will be here itself. It will be how much? It is N must be equal to mg plus mv0 square divided by r. Or we are getting this value v square to be equal to 2gr square root of that part. So it will be mg plus 2mg. It is 3mg. So this answer is correct. Maximum height with respect to the lowest point of the curved surface here attained by the block on the other side is r. We have already given the explanation for that part, so this is also the correct answer. The block performs SHM. Well, it will execute the oscillatory motion here about this point, but certainly it is not the linear SHM. In fact, I would not say it to be the SHM at all. So the option B and C are the only correct answer for question number 17. Now we shall proceed to question number 18, that is also based on the same paragraph. Here, if now this time the wedge is set free and then block is released, that means this is also set free and it's been released from here itself. So if it crosses to this point, let's say it is having the velocity v1, then the wedge shall have the velocity v2 along this direction. And by conservation of linear momentum, I would say 2mv2 must be equal to mv1, or v2 would be equal to how much? v1 by 2. Now yet again, by conservation of mechanical energy, the potential energy of this block would now convert to the kinetic energy of wedge and the block. So 1 by 2 2m into v2 square, it has to be written down as v1 square divided by 4 plus 1 by 2 mv1 square must be equal to mg into r, or 1 by 2 mv1 square, this is 1, this is 1 by 2, it is coming out to be 3 by 2, it must be written as mg into r. So we are getting this velocity v1 square to be equal to 4gr divided by 3 here. Okay, so maximum speed of the block, that was v1 itself. So well, that is the correct answer actually. It is square root of 4gr by 3. Fine. Maximum speed of wedge. Speed of wedge, how much it would be? v1 divided by 2. That means v2, it is gr by 3. So option A and option B both are the correct answer. Maximum normal force on the block is 4 mg. So we need to find the relative velocity of the block with respect to wedge. So how much it is? V. It is v1 plus v2. This is 2 root gr by 3 plus root gr by 3. It is 3 root gr by 3. So the normal force this time, it is N is equal to mg plus mv square divided by r. It is m r. It is 3gr. So 4 mg is the maximum normal force. Let's see if it's correct answer. Yes, option C is also the correct answer. Maximum height with respect to the lowest point of the curve attained by the block on the other side. It will fall to this point and yet again it will rise to the same level, and by the time it will rise to this height, it will have the velocity 0 and the wedge shall also have the velocity 0. That means it will keep on oscillating like this way and the wedge will keep on oscillating like this way. So the maximum height reached by this block on the other side is definitely, it is r. So for question number 18, we got all the answers as the correct answer. That means A, B, C and D are the correct answer. Now let's proceed to question number 19. Here also we are provided with the paragraph in which we have to answer two different questions, that is question number 19 and 20. Well, let's proceed with the question here. A convex lens mu naught to be 1.5, R1 to be equal to, this is the R1 20 centimeter, and R2, this is R2, it is 30 centimeter. Separates two media, mu1 is equal to 1.2 here along this direction, and mu2 is equal to 1.8 on this side is shown in figure. If the object is placed in medium of mu1 at a distance of 60 centimeter on the principal axis, then image formed, we need to find the distance of the image and its nature. Actually, this is I would say simplest application of the refraction through the curved surfaces there. So let's start with the first calculation. This is the situation. Object distance is how much? It is 60, and so this is mu1, this is mu2, and this part is mu naught. Fine. So for this calculation now, object distance is 60, so we shall be starting here as mu naught divided by v1, that is 1.5 by v1 minus mu1 by u. This is mu1 was 1.2, u was how much? Minus 60. So to be taken as, this is 1.5 minus 1.2 divided by R1, it was 20. Okay. For the second calculation, it is on this side, it is mu2, that is 1.8. V is the final position of the image, minus 1.5 v1 must be taken as 1.8 minus 1.5, and this is R2, this time it is minus 30. This one will cancel out. If we calculate this one, we will be getting 1.8 v plus 1.2 divided by 60, it will come out to be 1 by 50 here, and this is 1.5 minus 1.2, it is 0.3. This is 1 by 20 minus, this is yet again 0.3 divided by 1 by 30 here. Okay, so it is 1.8b plus 1 by 50 is 3 by 10 into 1 by 10 into 1 by 6. So it is 200. So that means 1.8 by v equal to 1 by 200 minus 1 by 50, that means 4 by 200, or minus 3 by 200. So what about v? V is 18 by 10 into 200 divided by 3 with negative sign, minus 120. Okay, now so for question number 19, actually image is virtual and image is formed at distance 120 centimeter from the lens. So option B and D are the correct answers. Now let's proceed to question number 20, that is also based on the same paragraph. Here this time, if an object is placed in medium mu2 at distance 90 centimeter on principal axis, then we shall be taking, well, this is the distance this time 90 centimeter, and the refraction will be taken along this direction. So for this refraction first, I'm taking this direction as the positive direction. It is mu naught, that means 1.5 divided by v1 plus 1.8 divided by 90 must be equal to 1.5 minus 1.8 divided by this R2 is 30. For another refraction here, this is 1.2 by v final image minus v1 would be equal to, this is 1.2 minus 1.5, and this is minus 20. Have this calculation in the same fashion as we did for the previous question. This one will cancel out, it is 1.2V plus it is 18 divided by 900, so it will come out to be 1890 into 10 5, so 1 by 50. Here it is minus 0.3 divided by 30, and here minus 0.3 divided by minus 20, so it is 0.3 divided by 20. 1.2V plus 1 by 50 equal to 0.3 divided by 10. 1 by 2 minus 1 by 3. It is 3 by 10 into 10. 3 minus 2, it is 1 divided by 6, or 1.2 by V equal to 1 by 200 minus 1 by 50, so it will be minus 3 by 200. So what about V? V is 12 by 10 into 200 divided by 3 with negative sign. So V is coming out to be minus 8 actually. So while looking into the options for question number 20, image formed is virtual. Yes. Image is formed at a distance of 80 centimeter from the lens. So option B and C are the correct answers. So that's the end of this question paper. Hope you must have appreciated the solution here, and I wish you all the best for the preparation. Thank you and goodbye.